So I think we can make a start now. It's 2 p.m. and it is my pleasant duty to welcome everyone to this webinar organized by the European Commission's Scientific Advice Mechanism. And we are dealing with the latest project of this mechanism, namely on solar radiation modification. And the question for today's webinar is, what should Europe's strategy be? Next slide, please. So I just a few words of welcome on behalf of Academia Europaea, which was the coordinator for this particular project. Each project of the scientific advice mechanism, and with this scientific evidence input from SAPEA, is led by one of the partners in SAPEA, Louise Edwards, the hub manager for the Academia Europaea hub in Cardiff. Will explain the scientific advice mechanism in a moment. But in this particular case, for the solar radiation modification project, it was Academia Europaea, and specifically Academia Europaea in Cardiff, that coordinated the project. So the European Academy, Academia Europaea, is one of the partners in SAPEA, Science Advice for Policy by European Academies, and is the only partner in SAPEA that is based on individual membership of people who are elected into the academy, simply based on their scientific or scholarly expertise. We have more than 5,000 members, and including a very large number of Nobel laureates and other very distinguished scientists and scholars. It operates uniquely, actually, in such an organization by a kind of distributed networks of hubs across the whole of Europe. And you can see this map of Europe, and the yellow dots represent the Academia Europaea hubs. However, the one hub that actually is doing the Academy's work for the scientific advice mechanism is Academia Europaea. And it's my privilege to be the director of the Cardiff hub in Cardiff, and luckily having a very efficient manager in Louise Edwards. So without going into the theme of this unquestionably very interesting webinar, I will now hand over to Louise Edwards, who has been the kind of coordinator for the whole of SAPEA's progress on this particular project. I apologize in advance that I will have to leave the webinar relatively soon because of another commitment, but I wish you all a very profitable and interesting and exciting webinar. So over to you, Louise.
Good afternoon, everyone. I'm going to start by advertising the webinar series that we're running on SRM. So there are two follow-up webinars that you might be interested in. One on the 3rd of February, looking at the social science aspects of the topic. And then in March, on the 11th of March, we're going to look in a little bit more detail about the technologies behind SRM. So do sign up for those if you're interested. Our speakers this afternoon, we have Dusan Hrenek from the European Commission, Eric Lambin and Naki Nakasenovic from the Group of Chief Scientific Advisors, Neil Eric Salin from the European Group on Ethics, Johannes Kwas from the SAPEA Working Group on SRM, and Ben Sovacool also from the SAPEA Working Group. The format of the webinar will provide a little bit of background. There'll then be 5-minute presentations from each speaker, and then we have an opportunity for audience interaction. So please use the Q&A box if you'd like to ask questions to the panel, and we encourage you to do that. Just a little word about who we are. We're the Scientific Advice Mechanism to the European Commission, the SAM for short, and we provide independent scientific evidence and policy recommendations to the College of Commissioners on any subject, including on issues that the European Parliament and the Council consider to be of major importance. There are three parts of the SAM. There's a SAM Secretariat at the Commission, the Group of Chief Scientific Advisors, and the SAPEA Consortium. Just a little word about them. The advisors are made up of 7 highly qualified experts from different backgrounds and different disciplines, and they make the policy recommendations to the Commission. SAPEA is an acronym standing for Science Advised by European Academies, and it brings together around 120 academies from 40 countries across Europe. And it's SAPEA that compiles the evidence for the advisors. The European Group on Ethics, we have a speaker from the EGE this afternoon, is an independent advisory body of the President of the Commission. And it provides advice where there's an ethical, societal, or fundamental rights issue connected with the development of science and new technologies. So my last slide, this is a process slide showing you how this science advice works. We receive a request from the commissioners. We review the evidence. The SAPEA working group reviews the evidence. The advisors make the policy recommendations, and we then deliver our advice back to the Commission. So taking this process step by step, we're going to start with Dusan Krenek, who's the Principal Advisor for the Directorate General for Climate Action at the European Commission. Over to you, Krenek.
Good afternoon. Thanks a lot for the invitation. And I would like to highlight at the beginning that we value a lot the work of the Group of Chief Scientific Advisors and also European Group on Ethics in preparation of both recommendations. I would like to explain a little bit the beginning of the request, why we decided to ask scientists for advice. Firstly, let me highlight the context of this request. Now we are facing a triple planetary crisis of climate change, biodiversity loss, and pollution. Regarding climate crisis, we have accelerated global warming. Recently, Copernicus Climate Change Service reported that last year, 2024, was the warmest year on record, 1.60 degrees Celsius warmer than pre-industrial level, and 10 last years were the warmest years on record. Furthermore, warming in Europe is even faster, and last year it was almost 3 degrees Celsius higher than pre-industrial temperature. Also, recent studies suggest that cleaner shipping fuels contributed to global warming. On one hand, they improve air quality, but also they were linked to record-breaking sea temperatures. We have also threats posed by Earth system tipping points and their potential cascading effects. And in this environment, there is a growing interest in solar radiation modification technologies. And when we were preparing, next slide, please. When we were preparing our joint communication on climate and security nexus together with the European External Action Service, we also look into solar radiation, SRM technologies. And we identify it as a risk. There is no clear scientific knowledge on impacts of SRM. The risk, impacts, and unintended consequences that SRM poses are poorly understood, and we have no necessary rules, procedures, and institutions for its management. Therefore, we highlighted it in this communication on climate and security, and also committed, guided by precautionary principle, that the EU will support international efforts to assess the risk and uncertainties of climate interventions, including solar radiation modification, and to promote discussions on a potential international framework for its governments, including research. Next slide, please. As a follow-up of joint communication on climate and security, for us it was evident that we need scientific advice. Climate policy, European climate policy, is science-based, and therefore we decided to ask the group of chief scientific advisors to assess risk and opportunities regarding SRM. In July 2023, former Executive Vice President Timmermans sent a letter asking Chief Scientific Advisor to give us advice on following two questions: on how to address risk and opportunities on research and potential deployment, and also to provide guidance, advice on options for a governance system for both research and potential deployment, considering different solar radiation modification technologies and their scale. Next slide, please. SRM raises also number of ethical, legal, political issues, and in order to get even more insight, better picture, in February 2024, former Executive Vice President Šefčovič asked the European Group on Ethics in Science and New Technologies to assess ethical aspects of SRM. He asked 3 questions on the most important ethical considerations on SRM, and also under which circumstances, if any, could development of SRM technologies and deployment could be considered ethical, and also about relevant perspective as regards to the international governments on SRM. And we got recommendations in December, and now let's look at the recommendation. Afterwards, I will make some comments and also how we are going to follow this recommendation, next steps for us. Thanks a lot.
Thank you very much. And now we move on to the SAPEA evidence review report. So it was SAPEA's job to compile the evidence on SRM. And we have with us the co-chairs of the working group, Johannes Kwas and Benjamin Sovokol. I think Ben might be having problems getting in, but let's start with Johannes.
Thank you very much. And yeah, my own background is in meteorology, but Benjamin and we were co-chairing a large team of experts across different disciplines in total 20 experts, not just different disciplines, but also different countries and career stages, and then where applicable, also different stances on solar radiation modification. And I'm particularly happy to see that many, or several at least, of the team are here in the audience. And so maybe their expertise can come in at a later stage as well. So the structure of the report was, after an introduction, 3 chapters that worked on elaborated on the science and technology background and on issues with solar radiation modifications. And then we had 3 chapters that looked at the social science related background and issues. And then in the end, we laid out what options could be for policies. Next, please. Louise, if you could, yeah, thank you. The background, as we already discussed, many thanks, is of course that we do not see global scale mitigation of climate change. So I put in a plot here of the global carbon dioxide emissions from fossil fuel, and you see that's in the last 50 years, and you see even the emissions increase, except for the slight dip during Corona. So if the emissions increase, obviously concentrations strongly increase. And so we haven't seen, despite all the agreements, high-level agreements, like the United Nations Framework Convention on Climate Change from 1992, we haven't seen the mitigation that is necessary to combat climate change, which is, of course, the stated goal. So if that continues, and if climate change has consequences, in particular, maybe particularly large, unexpected consequences, then in that framework, the question, of course, arises of solar radiation modification. What is it? It's a deliberate and potentially large-scale intervention in the Earth's climatic system, and that would aim to, well, maybe temporarily or permanently reduce some of the impacts of elevated greenhouse gas concentrations. Next, please. And the idea is, because climate change is driven by a change in the energy budget of the planet, to change that energy budget of the planet in the opposite direction. And that could be by reducing the amount of sunlight that is absorbed. And that means by increasing the reflection of sunlight. Or it could also be, there's also some ideas to potentially increase the emission of infrared radiation. In any case, the idea is to generate artificially, by intervention, by modification, a net cooling effect on climate. And the couple of things that are considered in the literature are the following 5, and that's the one which we assessed in the evidence review report. Stratospheric aerosol injection, an artificial volcanic eruption that puts a layer of aerosol into the level of the atmosphere which is above where the weather systems take place, so at a level where the aerosol has a longer lifetime. We see that aerosols change the cloud droplet number concentrations, make clouds brighter, for example, in the so-called chip tracks, and that could be done artificially. Then this idea to work with increased infrared radiation. Clouds have a greenhouse effect. I mean, they reflect sunlight, but they also have a greenhouse effect. And the cirrus clouds, it's the thin, high-altitude clouds, they have a strong effect. If one was able to thin these, then one would increase the infrared radiation that's emitted. One could paint surfaces bright and increase sunlight reflection there. Or, but I could already spoil and say this is really science fiction, in our opinion. One could, of course, also try to work in space, in not letting in a lot of sunlight into the Earth system. Thanks. Next, please. And what are potential effects, what are impacts, and what are side effects of SRM? Here, only a very superficial look at this. First of all, according to simulations, yes, solar radiation modification has the potential to counteract some impacts of greenhouse gases. but not others. For example, not the direct impacts of CO2, such as the acidification of the oceans. It would have regionally diverse impact on temperature. Yeah, in particular, solar radiation management requires sunlight, doesn't work in polar night. It works more in summer than in winter, not during the night, only during day. And it would also affect the hydrological cycle because rainfall patterns, they also are linked to the emission of infrared radiation, and that is not changed, obviously, by solar radiation modification. And it would have multiple other effects as well. Next, please. And yeah, what are technical and scientific requirements and prerequisites if one was to consider solar radiation modification? Number one is so far, and for good reason, as you see next, I mean, in what Benjamin will say, has been studied so far only in models. So it's only in simulations. But models are not yet able to anticipate all effects and impacts and may never be in some of the aspects. Some of the relevant processes, they are only causally integrated in models, for example, some cloud processes, or still missing entirely. But also, if one considers, then one would need to have a monitoring technology, also if it's not Europe, but some other actor that implements SRM. But in principle, such technologies to detect and quantify solar radiation modification exist, but some of these instruments are not yet European satellites, and we rely on partners, for example, in the United States of America. And in general, technology readiness level for all these schemes is low, for some even lower than for others. And then I think I hand over, right?
Sounds good, Johannes. Greetings, everybody. So one of the special things about the report is that it does focus on the non-technical elements as much as the technical elements, and that can be a little surprising because, as Johannes was saying, right, we don't yet have space-based geoengineering or widespread stratospheric aerosol injection campaigns, but social scientists have been studying this for 2 or 3 decades, trying to understand if we were to do those types of things, what would be some of the social reactions? What would be some of the actor coalitions? What would be the public's familiarity and ability to understand these very complex interventions, given they already may have trouble understanding more traditional climate interventions like mitigation or adaptation? So I'm really pleased that about half of the report covers the non-technical or social, ethical, political, and governance aspects of SRM, which is very refreshing, and also has hundreds, actually hundreds and hundreds of references that really support the technical references in the first half of the report. So one of the first things we looked at makes sense, right? If we were to deploy SRM, well, who are the individuals, organizations, institutions, and companies that might do that? And of course, the literature does suggest that it would be a lot of state actors, mostly because minimizing climate change is a public good. And so even if Saudi Arabia were to deploy space-based geoengineering, it would benefit everyone. So it's kind of hard to monetize. So a lot of our assessments did talk about how it would be mostly government actors or the military who might deploy and develop the aircraft, the satellites, the space-based sun shields. But there's also a surprising role for these other types of actors too. There are some startup firms that have begun to try to think about commercializing the technology. There are certainly civil society groups, environmental NGOs, but also those dedicated to SRM, like Silver Lining. And there are, of course, scientific bodies like ours, SAPEA, but others, including the Royal Society and the IPCC. And then we were surprised to find every country in Europe has a university researching SRM in some way. So that's kind of interesting that the actor networks are already coalescing. And in the report, we even show most of them have not come out for or against SRM. They are ambivalent or in the middle, which means they're kind of waiting to make up their mind. So that bodes well and ill for social deployment. It bodes well because opinions could still be formed, but it bodes ill because most everyone doesn't really have a strong opinion yet. And that leads me to this nice second point. When you take a step back from the actors that are involved to the public at large, they are not very familiar at all. And what we've done here in Figure 5 is we've taken data from 2 different sources. The one on the left is from Chad Baum and colleagues at Aarhus University, where they looked at more than 30,000 people across 22 countries, 11 in the global north, 11 in the global south. And one of the questions we asked them was, how familiar are you with these different SRM options? Three of which Johannes mentioned. So stratospheric aerosol injection, marine cloud brightening, and the space-based options. We could have added more, but we didn't want to make the survey too complex. And 1 means that they've never heard of it, and 5 means they're very familiar, and you can kind of see everyone is below the mean at 3. They're ranging between 1.5 and 2.5, which means basically not familiar. And interestingly, they say that they are the most familiar with the space-based options, which also is kind of wonky because those options, you know, other than maybe in James Bond films, they're not really dominating the SRM literature. It's SAI and cloud brightening and cloud thinning. And then Christina Merck has given us data from her surveys run in Germany, which also confirmed the same thing. And her data is really nice because it's year by year by year. So she surveyed the public there 4 times. So it's pretty consistent, and you can see only 2% of the public in 2017 said they felt they knew a lot about stratospheric aerosol injection. 83% have never heard of it. So again, this is kind of really starting to indicate that when people in the public may give their preferences, they may not really know what they're talking about. The last thing we did in this chapter on and stakeholder perceptions looked at experts. And so we presented the result of half a dozen expert elicitation studies that have asked people like Johannes what they think of the technology. And there, interestingly, most of those expert studies have found a lot of skepticism. We've got data that suggests people think these options will not be deployed until mid-century or later, which may make them too late. And we've also got people talking about how many of these options could have big risks, especially stratospheric aerosol injection or space-based geoengineering. So they do really reveal many, many points of concern. Louise, next slide. And sticking to that, you can see on the right this nice little traffic light diagram that is the result of an expert elicitation survey of, I think, more than 70 experts, many of which in Europe, where we asked them on a scale from 1 to 5 to kind of tell us about the challenges and barriers that face the options. And the way the traffic light system works is it's meant to be, as you get closer to red, it's a more significant challenge. So those dark reds are seen as very significant challenges. And when the expert elicitation exercise went through these challenges, I know it's kind of hard to read because they're sitting transversal to the table, but you can see on the left are just some of the technology challenges. All those other columns are other types of really interesting challenges like financing, social acceptance, regulation and governance, moral hazard, deployability, and so forth. And so what these options are telling us is that basically only where you see green do the experts say we won't have significant challenges. And there are not a lot of green on that traffic light. You can also see that some of the options like space-based reflectors and stratospheric aerosol injection and sunshades have the most red, which you can kind of mean have the most barriers. And this is a nice segue into another chapter of the report where we really laid out the complex, constantly growing literature on justice, ethics, and morality. The team did a great job breaking down justice not only into distributive justice, which would be kind of who allocates the resources for SRM, how do we distribute the costs and benefits, but also procedural justice. Who is making decisions? Is it Trump? Is it Elon Musk? Is it the European Commission? Is it the United Nations? And what is fairness and what is considered legitimate? What about issues of sovereignty and Native Americans and indigenous groups and minorities? What about recognitional justice that really spotlights vulnerable groups? For instance, if deployment worsens air pollution, what about those who already have preconditions for air pollution exposure? That's usually children, the elderly, people recovering from disease. So SRM deployment could harm them in ways that it wouldn't harm ordinary people who are not suffering from those conditions. And then we even talk about what's called rectifactory or corrective justice. If there is a mistake or an accident, who pays? What's fair? Who's compensated? We also discuss economics. Will SRM be cheap? When are its costs and benefits occurring in time? Where are they occurring over space? We also talk about the complex institutional architectures behind governing something as complex as SRM. At the global level, very challenging. At the regional level, challenging. At the national level, less challenging, but also less effective, because national deployment wouldn't necessarily be at the scale you would need to, say, save the Arctic or to save coral reefs. And then lastly, we do talk about, we had a great team of authors looking at geopolitical and security risks, including weaponization. Could they be used to control weather? Could they be misused? Could they be miscalculated and exacerbate conflict? Or could they connect with militarization, geopolitical entanglements, even terrorism? Or this nice term called termination shock, which is where if we were to deploy SRM and then stop deploying it, it could have rebound effects that are even worse than if we never deployed it in the first place. Next slide, please, Louise. And then, because of these nascent actor networks, lack of public familiarity, considerable degrees of challenges and risks, we then end by talking about governance and legal concerns. And we did a nice job in the report of talking about governance can be an enabler and a restrictor. You can have governance arrangements that incentivize SRM. They give tax credits, they give policy incentives, they do direct RD&D support, or restrict it and prohibit it all the way to a global ban, or from maybe things like wait and see, or for only legitimating deployment at smaller scales. So you could have deployment in a lab, but you don't go outdoors. And I like that these rationales for governance are shown here in this nice figure by Gupta et al., who was also one of the members of the working group. We also talk about how if you break SRM into its options, governance starts to be very technically specific. So in other words, SAI governance is different than marine cloud brightening. And so are the actor networks, and so are the scales, and often so are the technologies. And that does then lead to how you make scenarios can be very political because it's so specific to the unique context of space-time and actors and where they'll be deployed. We lastly had some legal experts in the team, and they went deep into law, environmental law, international law, even national law and European law, to go at all of those scales and talk about all the legal implications of SRM deployment from the level of, at the scale of experiments, right? All the way up to customary law, all the way up to European Commission law, and even global law. And we go all the way through the UN COP and framework for climate change. We talk about NMOD and restrictions on weather control. We talk about dumping and pollution treaties. We talk about also liability treaties and even the precautionary principle. So a really nice job teasing out what does the current law say, what are its gaps, and what changes might we need to make to create more robust legal frameworks. And then lastly, Louise, my last slide, I believe, is really talking about future work and talking about how do we weigh the costs and benefits of SRM, which was one of the key tasks given to the member working group. We have this nice diagram at the beginning of the report that really tries to frame SRM as a socio-technical system. That means it is about the technology. So you can see here infrastructure, many of the things Johannes talked about, aircraft, satellites, balloons, as well as innovation and knowledge networks. Who's doing the experiments? How are they doing demonstrations? How are we monitoring intellectual property? How are we consuming energy and resources? But also a whole host of other non-technical things, geopolitical ramifications, symbolic meaning, even things like how is SRM represented in films and science fiction? How do we set regulatory frameworks? How do we monitor biophysical impacts? How do we create a political economy that is inclusive, that actually minimizes poverty reduction and enhances participation among all actors, right? These are really difficult questions. And those kind of bars are meant to show that this is a system. So if you narrow in to only focus on infrastructure or only focus on culture, you miss other relevant elements of the system. So we really do hang our hat looking for the need for a systems approach for future work, which can be very challenging because no single person, not even Johannes and myself, have expertise in all of those dimensions. So you have to have interdisciplinary teams that understand all these attributes. It also points to how different pieces of the system shape other parts, right? So if you do have really bad biophysical impacts, that could increase the point about moral hazard, that we're only framing this as a solution by ignoring some of the hidden consequences. Or you could lead to what's called a slippery slope. Once you start to deploy, you create path dependence. That means we always have to deploy. That's the risk of termination shock. Or We also in the report talk about the sticky slope. It could go the other way, and once we start to deploy, there are kind of tranches of opposition that make future deployment impossible. And this already happened once at the experiment called Scopex in Sweden, where because of that experiment, which was denied, they actually stopped doing experiments for 5 years, that group. So there's an example of the sticky slope. All the way to other aspects like how do we think about regional equality, how do we think about uncertainty, how do we think about predicting probability, and how do we think about amplifying legal commitments across different member states. So we have a whole array of future things.
Another minute and we need to move on, sorry.
Please, that's it, I'm done.
Brilliant, lovely. Thank you. So that's the evidence, and we're now going to move on to the slide will move to the recommendations, the policy recommendations made by the advisors. So over to you, Naki and Eric.
Good afternoon. I'm really delighted to be in this webinar. And as you heard from Luis, Eric and I will be presenting the policy recommendations in our scientific opinion that is rooted in the evidence review report that Ben and Johannes just presented. So I will present the first two recommendations, Eric then the second two, and then I will conclude with the third one. But before that, I just wanted to remind ourselves of our terms of reference that Dusan already discussed. Basically, there were two objectives. One is to examine how EU can address the risks and opportunities of SRM, both in research and potential deployment. And the second one had to do with the governance system, also for research and potential deployment, with a special emphasis on technologies and their scale. And you have heard that was also highlighted in the evidence review report. Next slide, please. I would like to start with more a personal note before we go to our 5 recommendations. This is something that we're all familiar with. It's a global mean temperature increase, and please focus on the period after 1970s. And Dusan has already mentioned that as well. I would just argue, I started working in 1975 on climate mitigation, and I would argue that at that time the science was quite clear in which direction we are going if the mitigation if the emissions are not reduced. But perhaps very significantly, in 1975, Mihail Budicko published a paper about SRM. So the idea is 50 years old. And then in 1992, the US Academy had a very extensive report on all of the SRM technologies that Bob Schoch meticulously calculated. The cheapest option, by the way, was shooting sulfur into the stratosphere with naval guns. And the second option were the aircraft. And that's about the time when some of us started working on the AR, or the first assessment report of the IPCC. So as Dusan mentioned, probably the revival of interest has to do with the fact we are above 1.5 degrees already, as you can see, and are very likely to exceed 2 degrees. So this is, I think, one of the reasons why we have to look at all of the possible options. Next slide. And our first recommendation is actually a general recommendation that Europe should put at the highest priority emissions reduction and adaptation to climate change. That is important because of the Green European Deal, Fit for 55, 90% reduction by 2040 of the emissions, and net zero by 2050. So this needs to be the highest priority, also because we are very likely to overshoot the target, the stabilization levels of the Paris Agreement, and therefore other options need to be considered how we could go down. Now, the technologies and measures that should be emphasized include efficiency improvement, shift away from carbon-intensive energy sources, reduce emissions in land use, enhance the sinks, for example, through nature-based solutions, also carbon removal and storage, for example, in combination with sustainable biomass, could also result in negative emissions, and then carbon dioxide removal from the atmosphere. So our general recommendation is to continue actively and vigorously to invest in research and deployment of climate mitigation and adaptation. Next slide, please. Our second recommendation then is more specific about SRM, and we recommend the European Union impose a moratorium on SRM deployment as a potential measure for offsetting climate warming, but that this should be reviewed every 5 to 10 years because the science progresses. And the main motivation and the reason is, you heard already from Ben and Johannes, is that the risks are very huge of these technologies and the uncertainty is very high. And is likely to remain high for a while. The technologies are insufficiently understood from the point of view of the impacts and inherently also not predictable. This is why we recommend a moratorium because of this insufficient scientific knowledge. And also, you've heard that again in the evidence review report report that science, both modeling, observation, and theoretical considerations indicate that perhaps a little bit of temperature can be reduced, but not all of the climate warming can be offset, and certainly not other causes of climate change. So these deep uncertainties need to be recognized, and we also highlighted that they are inconsistent with the precautionary and do no harm principle. Next slide, and over to Eric.
So, of course, in addition, Europe should take the lead to negotiate a global governance system on SRM through a multilateral process that has great legitimacy. Of course, I think we've heard from Ben and why such a global governance system is so important. It could be under the aegis of one of the United Nations organization. There are multiple ones that could qualify for that. They should involve all countries, but they should also prevent unauthorized deployment, not just by countries, but also by private entities. And for this global governance system to be sound, of course, it has to involve, represent very strongly the perspective also of the global South, that is diverse, but has a very different, may have a very different view on that than the global North. And it should also include some elements on the transparency and information exchange related to SRM research, not just the deployment. And there are some equivalent agreements, such as the Nuclear Test Ban Treaty or Genetic Engineering Ban. So there are other topics that have been regulated in that way. As the EU negotiates with all the other parties such a global governance system, of course, we need to recognize that there are many international and EU legal obligations that are highly relevant for SRM, whether it's the do no harm principle, the international treaty on biological diversity, on the law of the sea, on human rights, on air pollution. So there are a whole range of existing treaties that, of course, will have to be completely consistent with whatever is negotiated here. Another key aspect is that this governance system should be based on a very broad and inclusive public consultation that really understands how different cultures, different societies perceive the risk and benefits associated with SRM. Another aspect, of course, in this governance system should deal with research, and that will be the next recommendation, but clearly some special clause on the ability to conduct some research and some limited experiments, outdoor experiments, should be regulated as well. And another key aspect also is the risk of military use of some SRM technologies. Now, there's already a convention on the prohibition of military or any hostile use of this technique that modify the environment. But again, here, great consistency with a new agreement on SRM and existing treaties is essential. As part of this global governance system, it's important to have some enforcement mechanism, but that needs to go further through an ability to detect any unauthorized deployments of SRM. And as Johannes mentioned, that does involve the launch of additional Earth observation satellites, especially the ones that are able to identify and monitor stratospheric aerosols, using LIDARs or other such tools. Next slide, please. Then the next recommendation is dealing with research. That is a very, very big piece of our work, and that's an area where we heard, a great diversity of views within the scientific community. It's very clear that there are very high uncertainties on the potential benefits and risks of SRM, and these uncertainties can only be addressed by further research. But research really dealing with the full range, from the technology itself to the physics of the atmosphere, all the way to the governance and the social perception of these kind of interventions. Now, this kind of research is very sensitive, in terms of potential impacts, not just on the atmosphere, but also on communities, on the biosphere, on the ecosystems, on food production, solar energy production, and therefore it's really important to have some guardrails, some mechanisms to ensure that this research is conducted in a very responsible way, with rigor and in accordance with basic ethical principles. So that involves, for example, create some outlining some clear ethical requirements, such as an obligation of full transparency on data, method, results. In some case, some pre-approval by an ethic board. Any social scientist has to have his or her research project being approved by an ethic board as soon as you talk to people. Same within the medical research. And this is a type of research where ethical screening might be relevant here. Now, it's really important to distinguish different types of research. The indoor research on your computer, doing simulation work, which is very different in terms of impacts from the outdoor research. And the latter, of course, can be very small scales with very limited impacts beyond the place of experiment, which is very different from the very large-scale experiments where you have these transboundary impacts well beyond the place of experiments. And so the ethical requirement will, of course, be different depending on the type of research you conduct. Now, this kind of research involves a number of concerns, ethical and justice concerns. And one of them was mentioned before already, is the risk of deterring mitigation, giving the false impression that, actually we don't need to mitigate climate change because we have this easy, handy solution there. But also outdoor experiments likely will have impacts on local communities. And of course, that if it's done without the prior consent of these communities, it will be in breach of some very basic ethical principle. Yes, another aspect we pointed to is the need to have a lot of transparency on what research is being done, which may require an international registry of this research where there's total transparency who is doing what. There's a special case of the outdoor research where we need to be very clear on what's the boundary between what's the small scale outdoor experiments with very little risk for communities and the biophysical system from the very large scale outdoor experiments, which could have caused significant harm to social societies, ecosystems, and etc. So that is very important to have some specific guidelines on that respect. And yes, but finally, we want to make sure that the public funding for SRM research is additional to any existing funding for climate change mitigation and adaptation, even though it's very clear that there's currently order of magnitude more money for climate change mitigation. But still, we want to assure that if there's interest in research on geoengineering, it doesn't kind of bite into the budget that's dedicated to mitigation. That's additional. Okay, yes, I think back to you, Naki.
Yeah, thanks, Eric. I'll be very brief. Our final recommendation is basically to reassess scientific evidence periodically, every 5 or 10 years or so, because it is likely to evolve very quickly into the future. And we have a number of sub-recommendations. Let me just highlight the 3 that are related to the progress of scientific evidence. The first one that would be required requirement is that the scientific community collaboration and international work is supported strongly, including the participation in intergovernmental assessments. So basically capacity building and knowledge building. We are also more specific. We are suggesting that citizen assemblies should be organized. That has been quite successful in many European countries on the topic of climate change in general, and I think it provides transparency and develops ideas about the fair governance. And in basically, it involves representative citizens of various countries. So from that point of view, I think it is very useful. And then, last but not least, let me also mention the detection attribution system that has to be put in place. And the reason is that Europe and European scientific community needs to be capable of detecting deployment and understanding where and attributing potential deployment of SRM. And I think this is particularly important in a possibility of a rogue deployment that could even involve private agents, might not be government organizations on their own. So I will stop here and we go over to Niels Erik to report on the European Ethics Group report. Thank you.
Thank you very much. We have, independently of the group of chief scientific advisors, written our report. And what surprised me is that when the reports were ready and finalized, how similar our recommendations are and how many things we very much agree on. One of the things that we say early in our opinion is that we must prioritizing the reduction of carbon emissions. And we say that this is because it's a much safer strategy. It's scientifically well understood, and we say that it's technically feasible up to a point. And it's a strategy that is far more predictable, have predictable outcomes. And this echoes what the chief scientific advisor says in their report. And we also emphasize that technical solutions are sometimes the way to go, but it is many times far more important to work in a way that changes social and economic practices, and that is also important here. I will want to emphasize one problem here, which we have touched upon today, and both Duncan and Benjamin talked about it, and that we all agree that SRM technologies are surrounded by extensive knowledge gaps. There are so many things we do not know. There are risks that we are not really capable today to assess. And the question then is, how do we take decisions when the uncertainties are very uncertain, when the risks are unknown? Next year, 1926, that is the centenary of the birth of the theory of rational decision-making. And that theory has been very important around the world. And one thing that shows this is that if you look at the Nobel Prizes in economics, many of the laureates have worked on that theory, developed it and used it. It is also a type of theory that has been used in policymaking. And what the theory of rational decision-making tells us is that we should maximize expected utility. If we are uncertain, maximize expected utility. And this will not do if there are huge knowledge gaps. We can't maximize in situations of that kind. And philosophers, economists, and others have tried to develop alternative theories. The problem is that none of the theories available today seem to help us in situation where the knowledge gaps are really big, and they are not capable of really helping us taking decisions when it comes to SRM technologies and SRM. The reason is that we have invented different type of rules for taking decisions, rules for deciding, and they come in conflict with each other. Different theories have different rules and they are in conflict. And the theory seems to violate very basic ideas of what a rational decision is. So this is not the problem that psychologists are talking about, that on and off we are as human beings not very rational or do not take sound decisions. It's not that. This is the fundamental theoretical problem that we have to think about. So what we recommend, the EG recommend and discuss in our opinion, is that the scale of uncertainty and the magnitude of the risks related to research into and deployment of SRM imply that it is necessary to identify the ethical values at stake. And we talked about that already. And in particular, we have to look at questions relating to justice, solidarity, inclusion, transparency, and accountability. But we also emphasize that we need to respect fundamental rights, including the rights of future generations. And including the rights of future generations make the decision-making even more difficult. We should invest, we say, in the development of better tools for value-driven decision-making under conditions of deep uncertainty. I think this is often forgotten and very important. And we also say that political decision-making should acknowledge and account for the scientific and technical complexity of SRM. And I was very happy to hear that Duncan said that that was one of the things that he was thinking about. So this is one recommendation, or some recommendations we have in the report. But we also have a number of other recommendations, and one of them is a recommendation to the European Commission. And we asked the Commission to issue a moratorium on any large-scale use of SRM within the territory of the European Union. And doing that, we also asked the Commission to work so there is for an international treaty committing to such a moratorium. And this is very close also to what has been discussed and the chief scientific advisors recommend. We recommend the member states to prevent SRM, including research into SRM, from becoming a lucrative opportunity for business, and discourage the development of a new market for SRM products and services. When it comes to the international community, we recommend the development of international regulations and governance mechanisms, including effective oversight and capacity to issue penalties. This has to be done. And we recommend the scientific community, and we have already touched upon that, to comply with the European Code of Conduct for Research Integrity. But that's obvious. But even more important is to expand the ethics review process of research aimed at development of SRM. And my colleagues have already mentioned that that's because there are so many different aspects when it comes to SRM. It has to do with nature, it has to do with society, it has to do with a lot of things. And there's so many different ethical questions hidden here that has to be discussed. So this was very quickly some of the recommendations in our report. The one, if you ask me on a personal level, I think is extremely important, is that we look into methods for a better way of taking decisions under deep uncertainty. We need them in order to deal with future questions of the kind that SRM is an example of. Thank you very much.
Thank you, Niels Erik. And we go back very briefly now to Brenik to close for us.
Thanks a lot. Firstly, I would like to express our gratitude to all scientists that they contributed to SAPEA evidence review report, and also scientific recommendations. In particular, I would like to express my thanks to Naki, Eric, Niels Erik, but also Johannes and Benjamin. DG Klima was extremely happy with the cooperation with the group of chief scientific advisors and EG in preparing their opinions. We valued the opportunity to engage and provide feedback. Scientific review and both opinions, they represent a balanced view reflecting a nuanced understanding of the issues at hand. What is important for the EU that its decision-making process is based on reliable and peer-reviewed information, taking into account all European policies, going beyond climate change. Next slide, please. The opinion of group of chief scientific advisors and AG, as well as the evidence review report, help us to fill the knowledge gap on solar radiation modification. But as it was highlighted by all speakers, we have many open questions and very difficult questions. What you did really a thorough work, huge work, identifying all issues. But to get answers, for that we need more work, more cooperation, and I would be glad to stay in contact and to cooperate on these difficult issues also in the future. The scientific advice is a key basis for consideration and deliberations on both on the European but also on international level. And we will take further actions taking into consideration the thoroughly elaborated recommendations and work towards European and international governments, ensuring transparent and inclusive oversight. The recommendations are very thorough, very sensitive, and reasonable. And already we are acting on some recommendations. What is important that we are also glad that as a first recommendation, it was highlighted that we need to continue in our policies, ambitious climate policies, and fulfilling our goals with reduction of emission for 2030, Fit for 55, but also reduction of minus 90% for 2040 and climate neutrality by 2050. Already when we publish joint communication on climate and security nexus, we highlighted that solar radiation modification, we do not consider it as a solution to climate change because it doesn't work on the main reason for global warming, and that it's increasing greenhouse gas emission concentrations. So for us, priority is to reduce emissions, to have climate neutrality and later negative emissions, plus to adapt to climate change and to build a resilience. On research, we consider that it's important to have good rules, that governance system. On that, we have a Horizon Europe project, Co-Create, that is helping us to address governance of research. We are also involved on international level on discussions on SRM, mainly in framework of UN Environmental Assembly. And regarding detection capacities, we are working with the European Space Agency, that it's now awarding to small studies to work on this, on cloud aerosol interactions in relation to SRM and also on detection capacity. But as you highlighted, really there is a lot of work to do, many difficult questions to address, and this is going to be a long-term process. But we think that it's necessary to address it, not to put aside, and to pay attention to SRM technology and to establish rules on European and international level. Thanks a lot. Really great work. We appreciate it, and we will build our actions on it.
So thank you, everybody. While I sort out the slides, we probably have 5 minutes now for questions, and we'll make sure all the questions are answered, and we'll follow up and perhaps with written responses. There's a question from Pascal, which is really for Johannes, and it asks, which satellites can detect SRM and how? Johannes.
Thank you. I had a brief answer in written, but just in words. SRM, of course, targets the Earth radiation budget. So Earth radiation budget instruments would be of relevance. The current ones are not European. So that's a key thing which we had in mind. But then again, of course, Eric also made the point, and it is evident. We also made the point in the evidence review report. Beyond this main target of the Earth radiation budget, there's also other quantities which we need to observe and monitor, and where also early detection might be possible, such as observations of the stratospheric aerosol layer.
And let's pick this one up. Who pays and how much is currently allocated for research? Does anyone know the answer to that? Give an estimate. Interesting. Let's move on. We'll follow up on that one. What grounds should an ethical board have for blocking SRM research?
Oh, I talked about that recommendation. So it's very similar to what's done for social science research and medical research, ensuring there's no harm to people who would be affected. Of course, if you do medical research, it's mostly the research subjects that you would protect through the ethical commitment. In this case, the people who affect may not even be informed or have given their prior consent to the experiment. So it has to be broader than a research subject. It has to include any group, social group, that potentially could be affected directly or indirectly by the research.
Niels Erik, any comment you'd like to make?
Yeah, I fully agree. And we have a similar problem in medicine when we have new technologies like gene editing and other things that we have to broaden the ethical review process. But as Eric says, here we have environmental questions. What we do in one place can affect people in another place. We need also, which not often is said, we need to make sure that those who do the reviews and are on the ethical boards really have the competence, the scientific competence, the ethical competence, the legal competence. That's very, very important.
Right, we'll finish with just two broad ones here that are nice. How realistic is it that the nations of the world can ever reach a consensus on the implementation of SRM? Anyone like to pick that one up?
I mean, obviously, the report doesn't speak to that directly, but I would say we have done it before in a few common collective problem areas, Montreal Protocol, abolition of slavery, things like that. And it could be that there's an external climate shock that somehow creates a unifying force in a way that we haven't seen it yet. Kim Stanley Robinson explores this in his science fiction book Ministry of the Future. So I think it's possible, although I certainly would say it is not probable.
Anyone else? I'm going to finish on this one. Andrew, under what circumstances will you recommend deployment? Or maybe you don't. Who'd like to answer that one? Ben, you were nodding.
No, I was hoping Naki might be able to do it, but I don't want to put him on the spot because I would be interested to know, Naki, your actual response.
Yeah, sure, Ben. I'll be happy. I would have given the floor to you, but it's okay. As far as, I can judge from the evidence review report and the rest of the literature, solar SRM can reduce the temperature by, say, 0.5 degrees to a degree, perhaps even a little bit more. And we talked about the risks that are there. So I would assume that a little bit similar to your response before, Ben, if there is some really drastic event, if we have, fundamental tipping in the Earth systems, which cannot be excluded today, then, I wouldn't be surprised if SRM is invoked as one of the, at least at the local level, as one of the options. And I think from my point of view, this is why it's warranted to say that as the science progresses, this should be revisited. The moratorium on deployment, large scale, should not be permanent. We should visit it as the science progresses. And then there might be some exceptions for the very, very small scale experiments.
Ben, any final comment from you on that?
No, excellent answer. And the recommendations in the report talk about a whole mosaic of different approaches, from stage gates to responsible monitoring to prohibitions in different forms and scales. And so I think it isn't as simple as prohibit or not. We get into really the details of which you could operationalize that in many different ways.
Good. Right. Well, we are 11 minutes over our allotted time, so I'm going to close at this point. And thank you to all of the speakers. Those of you that have put questions in that haven't been answered, we will follow up and we will answer them. So thanks to everybody for joining. Wonderful. And hope to see you on the 11th. All the best. Bye-bye.